Okay, let's get started. Welcome to my session about gRPC-Go architecture and features. This is a deep dive session, so I assume the audience to have some level of familiarity with gRPC-Go in general. My name is Yuxuan Li. I'm a software engineer at Google, and I've been working on the gRPC-Go project for about 2 years. Before we dive into the main topic of the day, I would like to give you guys a short and brief introduction to gRPC. Because you guys have been hearing about Kubernetes and many other stuff for the past few days, so I want to do a context switch with you guys. So what is gRPC? gRPC is a modern, open source, high-performance RPC framework. So it supports multiple languages and is a cross-platform. And we design our API carefully to make our components pluggable, so users can choose the implementation or even implement their own stuff that best suits their needs. And one more thing to highlight about gRPC is its rich features. We have core features like bidirectional streaming, flow control, and many other add-on features like binary logging, channelz, tracing. So it can help users better manage, configure, or debug the applications based on top of gRPC. This is a picture that illustrates our typical use cases. So end user on mobile, web, or desktop can use gRPC to communicate with microservices or access cloud APIs. And between microservices, they can also communicate with gRPC. Moreover, similarly, the microservice can still use gRPC to access those cloud APIs. So in summary, gRPC is a great tool to help users communicate transparently in a heterogeneous environment today. And here are some of our adopters, and there's just a few of them, and there's a lot more out there. This is just some examples, and our adopters, number of adopters are quickly increasing. As I said before, gRPC supports multiple languages, and among those languages, we have 3 implementations that's natively implemented. They are gRPC-C, gRPC-Go, and gRPC-Java. And all the other languages are wrapped around the gRPC-C core implementation. So today, I'm going to talk about the gRPC-Go implementation, which is one of the 3 native implementations. And a little bit of history about gRPC-Go. So we open sourced in February 2015, and we get a beta version out in September 2015. Next, we GA'd in August 2016, and we joined CNCF March last year. So the line here shows our GitHub repo stars trend, and you can see that we have a very good upward. We have a very good upward trend here, and we almost have almost 7,000 stars by today. Okay, now let's go to the main topic of today. So what I want to achieve from this talk is to give you guys a good foundation for understanding the core gRPC functionality. So later when you explore our code base, you feel more confident and more comfortable. I hope that by the end of this talk, you guys can have have a gRPC map in your mind. So when you later dive into our code base, you will never get lost. So gRPC is mainly about 2 things. First is managing the life of network connections, and the second is managing the RPC calls over those network connections. So this talk will be focused on these 2 things. So first, let's look at the code stack. So we have the transport layer on the bottom, and we have the HTTP2 transport by default. On top of that is the gRPC framework layer. It contains the main logic of gRPC. And the next is the gRPC API layer, and we also have another optional layer, or generated code API that's wraps around the gRPC API. In most cases, user interact with both generated code API and the gRPC API. So what are the operations involved in a gRPC? There are basically 4 of them. So both client and server can send header to set up the RPC call. And next, they can send a message, which is what an RPC is all about. And to end the RPC call, client can send the half close to server, so to let server know that it has done sending all the message it wants to send. And finally, server will send the trailer to client, which contains the final status of the RPC and mark the RPC as complete. So the picture on the right-hand side illustrates the 4 basic operations in a normal single request and a single response RPC setting. So client will first send the client header to set up the RPC call at the server side. Then it will send the request message to server. Next, it will send the half close to server to say that I'm done with sending all the messages. And the server will first send the header to client to set up the RPC at the client side. Then send the response message to client. And finally, send the trailer containing the final status of the RPC to mark the RPC as complete. In gRPC, we categorize RPC into 4 different types by the messaging pattern. So the first one is the unary. For unary type, basically, client will send a single message to server, and the server will send a single message back to client. And this is the most commonly used type of RPC nowadays. And the second type is the client streaming type. For this type, client will send a stream of message to server, and the server will respond with a single message. And similarly, for server streaming, client will send a single message to server, and the server will stream multiple messages back to client. Finally, the bidirectional streaming is the shorthand for bidirectional streaming. So for this type of RPC, there's no restriction on the message sent by the client or the server. And actually, gRPC implemented bidirectional streaming natively, and all the other 3 types are just special cases of the bidirectional streaming. The picture on the right-hand side illustrates the concept of bidirectional streaming. Essentially, there is a read-write stream on both client side and server side, and these 2 streams operate completely independently, allowing clients and the server to read and write in whatever order they like. Now let's go through the life of an RPC to explore the gRPC core functionalities. Here is the setup for our story today. So we all have a client that wants to root chat with the root guide service under the hostname abc.xyz. So root chat is a RPC method supported by the root guide service. It is a bidirectional streaming RPC type, and basically the client just exchanges the location info with the root guide service continuously. And let's also assume that for the hostname abc.xyz, we have 3 backends to serve a server under that hostname, which is a very common case nowadays to do load balancing. Okay, so the first step to make an RPC call will be to create a channel to transmit the RPC call if there's no existing one that you can use. So let's see how to create a channel in gRPC. Before that, let's define 2 very important concepts in gRPC, which are channel and the subchannel. So channel is an abstraction of a connection that an RPC can be issued to. You can simply think of it as a logical connection between client and the hostname target. Next is the subchannel. It is an abstraction over a connection and used for load balancing. You can simply regard it as a connection between the client and an individual backend. Now let's look at the step to create a channel. So the user will call the gRPC dial to connect to the hostname, and it prefixes the hostname by the scheme that the hostname is following. And here we are using the DNS scheme. And so gRPC got the dial function call. It will parse the target stream and start the resolver according to the stream. Here, since we are using the DNS stream, we'll start the DNS resolver. And then the resolver will go to resolve the hostname and return the addresses return the resolved addresses to the gRPC. And there's an optional service config that can also be reserved at the same time. And once the gRPC receives the address list, it will start a balancer based on the user config or the service config. Both of them can configure the balancer to be used for this channel. And so gRPC will start let's assume that the gRPC decides to use the round-robin balancer. So it will start the round-robin balancer and pass along the return the list of address to the balancer. So the balancer will, depending on its balancing policy, it will create connections to the it will instruct gRPC to create connections to the backends. A little bit about balancer here. So in gRPC, we implement two balancers, which are round robin and pick first. So for round robin balancer, it will try to connect to all the backends that returns by the resolver. And for the pick first balancer, it will connect to only one of the backends returned by the resolver. So and the pick first balancer is our default balancer in gRPC. So the balancer instructs the gRPC to establish the connections, and the gRPC will return a client count, which is an abstraction of channel in gRPC-Go to user. So user will later then use the client count to initialize the generated code stub that user can then invoke RPC method on top of. So let's zoom in and look at how balancer instructs gRPC to create those connections to the backend. So balancer will say, let's create a subchannel to IP address 1234 with the which is the first backend. And the gRPC will call the function create transport. And it will start the procedure to create a transport for that backend. And the transport will then tries to connect to the server. Essentially here is doing a network dial. And then on the server side, it received the signal that there is a coming connection request. So it will pass along the info to the gRPC saying that there's a new coming connection, whether you want to accept it or not. And gRPC will decide to, okay, let's accept the connection. And the transport will pass along the accept signal back to the client transport. And then the transport by now is like fully set up. So the transport will return itself as a ready transport to gRPC. So each subchannel creation process is following the step from 1 to 7, and the balancer may request multiple connections to be created, and they are all under the same procedure here. And now we have the channel. We are ready to create an RPC over the channel. So the RPC is started by the user calling the root chat method on the generated code provided stub initiated by the client count that returned by the gRPC. And then the generated code will call the new stream function to let gRPC know to create a new stream for the RPC. And a quick tip on here is that in gRPC, no matter what is the generated code layer stream or gRPC layer stream or transport layer stream, they all correspond to RPC code. So you can simply equal them, equal stream with RPC code when you're looking at our code base. So gRPC will try to create a new stream for the RPC. What it does is it will consult the balancer which subchannel it needs to use to create the stream, to basically transmit the RPC over. So the balancer will depend on its load balancing policy. It will choose a ready subchannel to transmit the RPC and returns the decision back to gRPC. And gRPC will then create the transport stream on the underlying transport of the chosen subchannel by the balancer and create a transport stream. And the transport will do the stream initiation by sending the header to the server side to initiate the stream also at the server side. And next, when the transport returns the transport stream to gRPC, gRPC will create a wrapper around the transport stream to provide functionality like compression, encoding, retry, and many other features, and return the wrapped stream to the generated code. And finally, generated code will create a very thin wrapper around the gRPC layer stream to provide things like type safety to the user, which is a much better programming interface for user to use. So let's look at how the call is initiated on the server side. Before we look into the steps, I want to clarify about our service handler registration a little bit. So usually, user will use generated code to help to have better programming interface. So user will write a user function based on the interface defined by the generated code, and it will register the user will register function with the generated code, and then generated code will create a wrapper around the user function to provide type safety and register the wrapped handler in the gRPC. So that's some setup here, and so on the client side, the transport sends the header to the client side to initiate a string. So the transport on the server side receives the header, and it creates a corresponding transport stream on the server side, and it will then pass the transport stream to gRPC. And like on the client side, the gRPC will again wraps the transport stream with its own stream abstraction to provide functionality like compression, decompression, encoding, things like that. And then the generated code will again create a thin wrapper around the gRPC layer stream and provides a nicer programming interface for user function to use. So, and it will invoke the user function to start the whole process. So now the client has a handler to send and receive message, and the server function also has a handler to send and receive message, so they can start communicating over the channel we just created. So client will send the request, call the send method on the generated code provider API. And then the generated code will call the send message on the gRPC layer provided API. And gRPC here will do the compression encoding here, and then it will call the transport layer write on the stream with the robot to be transmitted on the network. And then the transport will transmit the bytes over the network, and then on the server side, it will read the bytes of the stream and pass along to the gRPC, and then gRPC will do the decompression and decoding and pass along the message back to the generated code, and the generated code will pass along the request to the server. And the same send and receive procedure happens like for the server and the client. So basically, this is the read path and the write path of the whole RPC. And I would like to just stop here so you guys can look at how the RPC ends, which is very easy. So I would like to spend a couple minutes here to introduce some of our nice features of gRPC. So like I said before, we have a pluggable components, and some example here are resolver, balancer, IDL, compressor, codec, and transport. For example, for IDL, so that means being pluggable means that you don't need to use protobuf to be able to use gRPC, which gives user much more flexibility here. And also, I would like to briefly introduce some of our recent features, like binary logging, channelz, and service config. For the other feature, I don't have time to introduce here. You can go to our repo and see the detailed design doc. And first, the service config. service config provides a way for service owner to publish parameters to be automatically used by all clients. So how to set up the service config? The service owner will need to push the service config file to a service config hosting service, for example, a DNS server. And when the gRPC client tries to resolve the hostname, it will try to see whether there's a service config under that hostname. And if there is, it will pass along to the gRPC client. And the gRPC client will then apply the service config constraint to all the RPC for the connection under that hostname. And for example, so what's included in the service config? For example, there are so it contains the load balancing policy. So the server can the gRPC service provider can let all its clients use the round robin server use the round robin server. And it also says about the RPC timeouts or the request response message size limit. And actually our new features like RPC retry or health checking, they are all integrated with the service config. So essentially you can pass the configurations through the service config. And next, the binary logging. Binary logging logs RPCs in binary format. Basically, it just logs all the RPC operations in a binary format, and along with the timestamp and the call ID. And the user needs to provide a logger interface, logger to log it in any place you'd like. And so a typical use case for binary logging is to do troubleshooting service finding exception during load testing or replaying production RPCs. And finally, the channelz service. So channelz is a tool that provides comprehensive runtime info about connections at different levels. Basically, you need to export a channelz service in your binary, and it will serve the you need to serve the gRPC. You will serve the gRPC service. So the end user can get the info from those services. And what are the info provided by the channelz? So you can inquire like how many calls has been started, succeeded or failed at a channel or subchannel, and what is the security info about the transport, like what is the cipher suites, what's the certificate used to set up this transport, and flow control info, like how many flow control window you currently left for this transport. And for example, also info like what is the last RPC on the channel and how many streams are alive currently on the transport. And there's a lot more there. Please explore them yourself. And I have wrote a very short introduction to channelz. You can find the link on the bottom. And so channelz can be super helpful when in regards like debugging network issue or performance issue or even configuration issue. And then that wraps up my presentation. Let's go to the Q&A. Oh, you mean the quick transport? So gRPC doesn't support quick transport, but I think the Java or C++ information, they do support quick transport. You mean the integration plan for gRPC-Go implementation? I think like right now, so I've like said here, we have the transport to be pluggable. That feature is coming soon, so we are trying to make our transport pluggable. And after we made that change, then we may work on the quick transport support. Yeah.
May I ask, binary pattern to the gRPC? Is the load balancing work that way?
Can you say that again?
If I use
a unary
pattern, is the load balancing?
Yes, yeah. The load balancing is like across all types of gRPC. It basically just decides for this RPC, no matter what type it is, where it should go through, which channel it should go through, which connection.
So, for example, if I have the clients calling several the same gRPC server with several endpoints. So you load balance.
Yes.
Because it is sub-connections.
Right, it will load balance on those sub-channels.
Where the config located? Where is config? IP.
You mean where you can configure the balancer? So we provide a peak first balancer and a round robin balancer by default. So if you want to any other behavior, you need to implement the balancer yourself, so you can decide all the behavior you want. We have a nice balancer API. You just need to implement that to interact with gRPC.
Is there a default one?
There's the default one is the peak first. So essentially, when there are multiple addresses returned by the resolver, it will try to connect to one of them. If that connection succeeds, it won't try with other backends. Yes. You mean whether we support connection pool? Why do you need a connection pool if you already have a load balancer, so you can manage all the connections through them? I don't see why you need a connection pool. You just have so the channel will include like multiple sub-channels. So when you right, so that's what sub-channel means.
Yeah, it takes codes to open and close the sockets. Just want like 100 sockets running.
So you mean like you just need to connect to the backend once? So you only need to you don't need a connection pool. The connection is there. You can just to start RPC on those connections. Right. So the sub-channel is essentially does TCP connection. So maybe let's take the question offline, probably. Yeah. Okay. Okay. Thank you.